Okay, so we're going to explore how to figure out if two triangles are similar. Well, any two shapes are similar, but first let's look at triangles. Now, triangles have this great property of we know what all the angles add up to. So the first I'm going to do is I'm just going to record what information is given, because I have to know what information is given before I can figure out what other details I can calculate, I can conclude. So given, I have angle B is 47, angle A is 28, angle K is 107, and angle D is 28. Well, I have one set of angles that's corresponding, so that means that A and D would be corresponding. What I don't know is if F and K, or F and C, F and B, or K and C are the same. They look like they are the same, but I need to figure that out. So in a triangle, I can say all angles are add up to 180, so I can subtract one angle. That gives me 73, and then I can subtract the other angle, and 73 minus 28 is 45. So I know that this angle is 45, okay? Now this triangle has a 45-degree angle. This triangle has a 47-degree angle. So I know that I can't have all three angles be the same, because even if this one were the same as this one, these wouldn't be the same. In fact, we know that this one can't be the same because they all have to add up to the same thing. So if 107 plus 28 plus 45 is 180, then if I have 2 more degrees here, I'd have to have 2 less degrees here. And if you check that, those do add up to 180 degrees. So because not all angles are the same, so these are not similar, okay? If I did have a similar triangle, right? A similar triangle would be one where I had a 47 degrees, a 28, and a 105, right? So a similar triangle, if I had one like this, then I could say, well, between 47 is 28, between 47 and 28 is 12, between 47 and 28 is 8, so I'd say 8 times my scale factor is 12. And I could figure out what the scale factor is and figure out what the other sides are. So in this case, we'd say, well, K is 12 eighths. 12 eighths reduces, I can divide both of these by 4, to 3 halves. So I'd say my scale factor for here to here is 3 halves. But for this one, there is no scale factor because they are not the same angles, so they're not similar. So you can only use a scale factor if you have similar figures. And since we've proven that they are not similar, you can't find or use a scale factor because the sides would not be multiplied by the same thing. Now, it's different when we're talking about things that aren't triangles, because you can see we've got 4 90-degree angles and 4 90-degree angles here. So we know all angles are the same. All angles are, in fact, I should say all corresponding angles are the same, okay? But since they're not triangles, we don't know that they necessarily add up to the same thing. We can't match and say, oh, look, all angles are the same, therefore they're the same shape. We have to check, is the scale factor consistent? And that is, am I multiplying by the same thing each time? So I can see that my longest side here is 14, and my longest side here is 6. and my shorter side here is 4, and my shorter side here is 12. Well, if I'm going from 4 to 12, k would be 3. But if I were going from 6 and k were equal to 3, then this would be 18. So 4 times 3 is 12, but 6 times 3 is not 14. So no consistent scale factor. So not similar. If we were finding a similar shape, instead of 14, it would be 18. So if this were 18, then it would be similar, because the scale factor would work on all corresponding sides. So that's a little example of how to tell if two shapes are similar. If they're triangles, we can look at the angles. If we know all three angles, we can compare the angles, and that's enough information. If they're not triangles, then the only way to determine if they're similar is to see if they have the same scale factor, if they're proportional. Now, you'll find some on your CYU worksheet that are triangles, but that we don't have all three angles. We don't have enough information of angles. So in that case, you'll have to look at one of the videos where it talks about looking at the proportions in triangles to figure out similarity.